Now let us start Euclid's division algorithm. Before we go to Euclid's division algorithm, let us take a brief look at Euclid's division lemma. What is meant by lemma? Lemma is a proven statement which is used to prove another statement, or we can say that lemma is a proven statement which can be used as a stepping stones to a larger result. A small theorem. It is called lemma. Who is Euclid? In lower classes you have studied about Euclid, an ancient Greek mathematician from Alexandria. That's Euclid. So first we will take a look at Euclid's division lemma. This algorithm is based on this lemma. So Euclid's division lemma says that for given two positive integers a and b, there exist unique integers, q and r such that a is equal to bq plus r, where r greater than or equal to 0 but less than b. This is Euclid's division lemma. It is not a confusing one. It is very simple one. This equation you have already studied in lower classes. To check the accuracy of the division, just we will look at after some time. Yes, you have studied all these things. One important thing, this lemma was first recorded in books 7 of Euclid's Elements. That is, Euclid's Elements is a mathematical treatise which contains 13 books, and it contains proportions, theorems and proof of proportions, all these things. And it is attributed to the Euclids, a mathematician. This Elements is attributed. And one important thing, you don't never forget that thing. This element is a second Bible in the number of editions already published. This lemma says that for given two positive integers a and b, there exist unique integers. That's very important. These unique integers, one and only integers, the particular integers q and r, such that a is equal to bq plus r. This letters q, r is not in its original form, as described by Euclid. These letters are attributed to this lemma in later time, in the 19th century. These letters. Just we will look at this lemma little bit detail. This is a lemma. For two given integers, positive integers a and b, there exist two integers, unique integers q and r such that a is equal to bq plus r. So there is no strict rule to write always q after b. There is no strict rule, but it is convention. Why? This q is the short form of quotient. It is not recorded in original Elements of Euclid. This letters is attributed to this lemma in later time, and r is the remainder, short form of remainder. I have already told you that this equation is used to check the accuracy of the division in lower classes. Let's maybe take it. For a, we can say dividend, this b divisor, this q quotient plus this r remainder. This we have already studied. Actually, this is not the lemma. During this is the preparation of this time. This on ancient 300 BC, the division process was not used. It is not prevailed at that time. At that time for division, they use successive subtraction. So after the invention of this division, the letters Q and R are used. Equal to 39 and B is equal to 5. In lower classes, you have studied that how to divide A by B. A is the dividend and B is the divisor. Am I right? Then 39 by 5, 7, 35, 4. So we can write it as 39 dividend is equal to divisor 5 into 7 plus 4. This is what? Am I right? 7 is Q. This is 7 quotient. R is 4. The value of R less than B. Is it? This is B less than B and greater than 0. When this R is equal to 0, very simple. That is, we can relate two numbers with the help of unique two integers Q and R. In this way, A is equal to BQ plus R. One important thing, the value of the R is greater than or equal to 0 but less than B. If R is equal to 0, we say B is the factor of A. Or we can say that A can completely divisible by B without leaving a remainder. This is the lemma. Euclid's division lemma. Now let us look at some other examples to check the Euclid's division lemma. Find Q and R for the following pair of numbers 10 and 3. We have to find Q and R. Here A is 10. Am I right? Here A is 10. B is equal to 3. How can we write? Don't get confused. We can use this on division method. It is not allowed, but it is the easiest way to find Q and R. 10, 3 times 9, 1. So how can I write? 10 is equal to 3 into 3 plus 1. This 3 is this one. So here it is Q is equal to 3, R is equal to 1. We have to find Q and R. Here A is equal to 4, B is equal to 90. We have to find 4 is equal to 90 into Q plus R. We have to find easiest way. 4, 90. How can we divide? How many times? 0 times. That is 4 is less than 90. 0 times 0, remainder 4. Am I right? This is R. R should be less than this one 90. So this is equal to 19 into 0 plus 4. So Q is equal to 0, R is equal to 4. Am I right? 3. Here A is 81, B is equal to 3. So 81 is equal to B into Q plus R. So 81, 3. How many times? 2 times 6. 2, 1, 7. 21, 0. So that's equal to 3 into 21 plus 0. No, 27. 3 into 27 plus 0. So Q is equal to 27, R is equal to 0. This way we can find.